Imagine a civilization so advanced that it could harness the energy of an entire star to power its technologies, fulfilling all its energy needs for millennia. This might sound like science fiction, but it's a concept rooted in serious scientific thought: the Dyson Sphere. What exactly is a Dyson Sphere, and how does it relate to the search for advanced civilizations? Let's dive into this fascinating idea that bridges science, engineering, and the quest to find intelligent life beyond Earth. 1. The origin of the Dyson Sphere concept. The term Dyson Sphere originates from the visionary physicist Freeman Dyson, who published a paper in 1960 titled Search for Artificial Stellar Sources of Infrared Radiation. Dyson proposed that highly advanced civilizations, classified as Type 2 on the Kardashev Scale, would need enormous amounts of energy to sustain their technological growth. Instead of relying on planetary resources, they might build megastructures around their star to capture and utilize its energy output. To put this into perspective, the Sun emits approximately 384.6 yatawatts of energy per second. Earth receives only a fraction of this, roughly 0.000000045%, and yet that fraction sustains all life and human technology on the planet. Dyson theorized that an advanced civilization could tap into the remaining energy by constructing an enormous shell or swarm around its star. 2. Types of Dyson spheres. The idea of a Dyson sphere has evolved over the decades, giving rise to several theoretical designs. 1. Dyson swarm. This is the most realistic and practical model. Instead of a single solid shell, it consists of countless solar collectors, satellites, or mirrors orbiting the star in a coordinated manner. Each collector captures solar energy and transmits it wirelessly to the civilization. 2. Dyson bubble. A variant of the swarm, where solar sails or lightweight structures form a bubble-like arrangement around the star. These sails are held in place by radiation pressure and gravitational forces. 3. Dyson shell. The iconic version often depicted in science fiction. It envisions a solid sphere encasing the entire star, with habitats and solar panels on its inner surface. However, this design poses immense engineering challenges, including structural stability and material requirements. 4. Dyson ring. A simpler concept involving a ring of solar collectors around the equator of a star. Though less efficient than a swarm or shell, it represents a stepping stone for a developing civilization. 3. Feasibility and challenges. Building a Dyson sphere, even in its most modest form, would be a monumental task. Consider the following challenges. Material requirements. To construct a Dyson swarm around the Sun, a civilization would need vast quantities of resources. The entire mass of Mercury, for instance, might be used as raw material due to its proximity to the Sun and abundance of metals. Energy and time. Mining, manufacturing, and assembling such a megastructure would require energy outputs far beyond what humanity currently possesses. It might take thousands, if not millions, of years to complete. Structural stability. A solid Dyson shell would face immense gravitational forces and thermal stresses. Without revolutionary materials and engineering techniques, it would likely collapse or disintegrate. Coordination. Even a Dyson swarm would need precise orbital synchronization to prevent collisions and ensure efficient energy transmission. Advanced AI and robotics would be essential for such coordination. 4. Dyson spheres and the search for extraterrestrial intelligence, SETI. The concept of Dyson spheres has profound implications for the search for advanced civilizations. Astronomers have theorized that such megastructures would emit detectable infrared radiation as waste heat. Dyson's original paper suggested searching for such infrared signatures as a way to identify Type 2 civilizations. In 2015, the star KIC 8462852, nicknamed Tabby Star, captured global attention. Observations revealed unusual and dramatic dips in its brightness, leading some to speculate that a Dyson sphere or swarm might be under construction. While subsequent studies attributed the phenomenon to natural causes like dust clouds, the incident highlighted the scientific interest in Dyson spheres as a potential marker of extraterrestrial intelligence. 5. A step closer to the stars. Although the Dyson sphere remains a theoretical concept, it reflects humanity's aspirations for the future. As we advance technologically, we may take incremental steps toward harnessing solar energy on a larger scale. Projects like space-based solar power systems, SBSPs, and orbital solar farms are already in development, providing glimpses of what might one day lead to a Dyson swarm. This idea also serves as a reminder of our cosmic insignificance and potential. If such megastructures exist, they would signify civilizations millions of years ahead of us in technological evolution. What could we learn from them? Could they offer solutions to challenges we face, like climate change or resource depletion? With that, we've only scratched the surface of the Dyson Sphere concept. In the next section, we'll explore its broader implications, such as how it fits into the Kardashev Scale, the theoretical possibilities for interstellar communication, and its portrayal in science fiction. 6. Dyson Spheres and the Kardashev Scale. To understand the significance of Dyson Spheres, we must explore their connection to the Kardashev Scale, a framework introduced by Soviet astronomer Nikolai Kardashev in 1964. This scale categorizes civilizations based on their energy consumption and technological advancements. 1. Type 1 civilization. A planetary civilization capable of harnessing all the energy available on its home planet. Humanity, as of now, is classified as a Type 0.72 civilization, using only a fraction of Earth's available resources. 2. Type 2 civilization. A stellar civilization that can capture and utilize the total energy output of its star. Constructing a Dyson Sphere or Dyson Swarm would be a hallmark of reaching this level. 3. Type 3 civilization. A galactic civilization that can control energy on the scale of an entire galaxy. Such a civilization might build Dyson Spheres around many stars, creating a network of energy-harvesting megastructures. Dyson Spheres represent the critical leap from Type 1 to Type 2. They symbolize not only a mastery of energy but also the ability to manipulate celestial bodies and materials on an astronomical scale. 7. Implications for space exploration and communication. If Dyson Spheres exist, they might serve purposes beyond energy harvesting. Advanced civilizations could use them for communication, exploration, or even survival. 1. Interstellar communication. A Dyson Swarm could be modified to act as a massive beacon, transmitting signals across the galaxy. This might be how Type 2 civilizations announce their presence to others, potentially bridging the communication gap between species separated by light years. 2. Expansion and colonization. Once a civilization constructs a Dyson Sphere, it could use the energy surplus to fuel interstellar travel. This would open the door to colonizing other star systems and eventually reaching Type 3 status. 3. Planetary defense. Some theorists suggest that Dyson Spheres could shield planets from cosmic threats like asteroid impacts, gamma-ray bursts, or supernovae. By absorbing or redirecting harmful radiation, they might ensure the survival of an advanced civilization. 8. Dyson Spheres in science fiction. The concept of Dyson Spheres has captivated the imagination of writers and creators for decades. Science fiction often portrays these megastructures as technological marvels, symbolizing the zenith of human or alien ingenuity. 1. Star Trek. In the Relics episode of Star Trek, The Next Generation, the crew encounters a Dyson Sphere enclosing a star. The structure is depicted as a massive habitat capable of supporting trillions of inhabitants, though its creators remain a mystery. 2. Isaac Asimov's Foundation series. While not explicitly about Dyson Spheres, Asimov's works explore the concept of utilizing stellar energy and the potential of advanced civilizations. 3. Larry Niven's Ring World. Although a Dyson Sphere isn't the central focus, Niven's ring world envisions a colossal ring encircling a star. This structure shares similarities with the Dyson ring concept and raises questions about engineering and sustainability on a cosmic scale. 4. The Three-Body Problem by Liu Cixin. This modern sci-fi masterpiece touches on advanced alien civilizations and their potential to manipulate their surroundings, echoing the idea of stellar energy harnessing. Science fiction not only popularizes the idea of Dyson Spheres but also inspires scientists and engineers to ponder their feasibility. What was once confined to novels and films now fuels real-world research in astronomy and space exploration. 9. Could we detect Dyson Spheres today? Astronomers have developed methods to search for Dyson Spheres using telescopes and advanced imaging technologies. These efforts focus on detecting the waste heat emitted by such structures, which would appear as excess infrared radiation. 1. Infrared surveys. Projects like NASA's Wide Field Infrared Survey Explorer, WISE, have scanned the sky for anomalies that might indicate the presence of Dyson Spheres. So far, no conclusive evidence has been found, but the search continues. 2. Tabby Star and Similar Mysteries. As mentioned earlier, the unusual dimming of Tabby's star raised speculation about the presence of a Dyson swarm. While natural explanations prevailed, such observations highlight the importance of considering all possibilities when studying cosmic phenomena. 3. Exoplanet research. With missions like Kepler and TESS, astronomers have identified thousands of exoplanets, some of which orbit stars with intriguing energy signatures. Could one of these systems harbor a Dyson sphere? 10. Philosophical and ethical questions. The idea of Dyson spheres raises profound philosophical and ethical questions. What defines progress? Would the construction of such megastructures signify true progress, or might it lead to unintended consequences, such as environmental destruction on a cosmic scale? Are we alone? If we never detect a Dyson sphere or similar structure, does it imply that advanced civilizations are exceedingly rare, or that they follow entirely different trajectories of development? Should we attempt it? As humanity advances, should we strive to build our own Dyson sphere, or focus on more sustainable methods of energy generation? The answers to these questions could shape humanity's future, not only as a planetary species but as potential explorers of the stars. 11. Humanity's journey toward stellar megastructures. Creating a Dyson sphere or even a Dyson swarm is a challenge far beyond humanity's current capabilities. However, as technology evolves, we are slowly taking steps in the right direction. This section explores the prerequisites for building such a megastructure, from energy advancements to the societal and philosophical changes required. A. The energy revolution. The first step in humanity's journey toward building a Dyson sphere involves solving our current energy challenges. To become a Type 1 civilization, we must master the full use of Earth's resources, including nuclear fusion. As the process that powers stars, nuclear fusion represents an almost limitless source of clean energy. If we achieve sustainable fusion reactors, we will possess the technological foundation for large-scale energy projects. Space-based solar power, SBSP. This concept involves placing solar panels in orbit to capture solar energy without atmospheric interference. The energy is then transmitted wirelessly to Earth. This technology could serve as a precursor to Dyson swarms. B. Mining the solar system. A Dyson sphere would require unimaginable amounts of raw materials. To gather these resources, humanity would need to mine celestial bodies, including asteroids, rich in metals like nickel, iron, and platinum. Asteroids could provide the building blocks for constructing solar collectors and satellites. Planets and moons. Mercury, with its proximity to the Sun and abundance of metals, is often cited as a prime candidate for disassembly to build a Dyson swarm. Similarly, moons like Europa or Titan might offer other essential resources. C. Robotics and artificial intelligence. The sheer scale of a Dyson sphere necessitates the use of advanced robotics and AI. Self-replicating robots, these machines could mine materials, manufacture components, and assemble solar collectors autonomously, scaling the construction process exponentially. AI coordination. A Dyson swarm would require precise synchronization to avoid collisions and ensure maximum efficiency. AI systems capable of real-time adjustments would be essential. 12. Societal and economic shifts. For humanity to embark on such an ambitious project, significant societal and economic changes would be necessary. A. Global cooperation. Building a Dyson sphere would be a multi-generational project requiring the collective efforts of the entire planet. This would necessitate unprecedented levels of international collaboration and the resolution of geopolitical conflicts. B. Long-term vision. Modern societies often prioritize short-term gains over long-term projects. Constructing a Dyson sphere could take thousands of years, demanding a cultural shift toward valuing intergenerational progress. C. Ethical considerations. The disassembly of planets or moons raises ethical questions. Would humanity have the right to alter celestial bodies on such a massive scale? How would we balance exploration with preservation? 13. A glimpse of the future. A. Megastructures of tomorrow. While a full Dyson sphere remains a distant goal, humanity is already experimenting with smaller-scale projects that could pave the way. Orbital solar farms. Organizations like NASA and private companies are exploring ways to beam solar energy from space to Earth. Starshot projects. Initiatives like Breakthrough Starshot aim to develop light-powered spacecraft capable of interstellar travel. These technologies could one day support the construction of Dyson swarms. B. Beyond energy. The role of Dyson spheres. A Dyson Sphere would be more than just an energy source. It could enable artificial habitats. The inner surface of a Dyson shell could house trillions of individuals, creating a new frontier for human settlement. Terraforming. With virtually unlimited energy, humanity could terraform planets, turning barren worlds into habitable ones. Cosmic exploration. Harnessing a star's energy could fuel spacecraft capable of traveling vast distances, unlocking the mysteries of the universe. 14. The search for existing Dyson spheres. As our technology improves, so does our ability to search for advanced civilizations. Projects like SETI continue to scan the skies for unusual signals, while infrared surveys look for waste heat signatures that could indicate the presence of megastructures. 15. The final question: will we build one? The idea of a Dyson sphere inspires both awe and skepticism. It represents the ultimate expression of human ingenuity and ambition, a testament to what we might achieve if we work together. But it also challenges us to rethink our relationship with the universe, our ethical responsibilities, and the kind of legacy we wish to leave behind. So, will humanity ever reach the level of technology and unity required to build a Dyson sphere? Or will we remain confined to our small blue planet, dreaming of the stars but never reaching them? What do you think? Could a Dyson sphere be humanity's ultimate destiny, or simply a beautiful thought experiment? Share your thoughts in the comments, and let's continue this fascinating conversation about the future of civilization and the mysteries of the cosmos.